Hello, class. In our last video, we started tackling the topic of solving quadratic equations. So up to this point, we've learned factoring methods so that we can solve the types of quadratic equations that can be solved using the zero product property. But there are two more types of quadratic equations that you probably don't want to try factoring to solve them. There may be an easier way to do that, okay? So we're going to talk about these two types of quadratic equations that you want to be on the lookout for. So let's go over here and jump into the PowerPoint just so we can see what are these two different types of quadratic equations that we need to be aware of. Okay, so as we've mentioned, there are three main techniques that we're going to use to solve quadratic equations. The first one was factoring. And usually if we have um, something that has a greatest common factor, a polynomial that has three terms like a trinomial, then we want to go ahead and try factoring to see if we can use the zero product property and then break up our quadratic equation into two linear equations that we can solve more easily. Okay, but we covered that in our last video. In this video, we're going to talk about the square root property and then the quadratic formula. So you're going to need to be able to, when you look at a quadratic equation, that is, discern or decide for yourself which of these methods do you need to use to solve the quadratic equation. Okay. So hopefully I'll be able to give you some tips and tricks here to identify when to use which method. But if you need some refresher, then just make sure you go back and watch the video on solving quadratics by factoring and using the zero product property. Okay. So for now, imagine that you're confronted with the following quadratic equation, 3x squared minus 12. Okay. In previous iterations of these quadratics, we saw that we usually have maybe three terms, and we would write that quadratic equation out in standard form, ax squared plus bx plus c equals 0. Okay. But this only has two terms. Okay. So there's a couple of ways that you could approach this. I'm going to go ahead and write this down on paper so we can see it worked out. Okay. So imagine that we're dealing with this quadratic 3x squared minus 12 equals 0. Okay. Well, the first thing that you might want to do is you might try to factor this thing. Okay. That might be a useful method. So you might say to yourself, well, one, let's factor. And if you look at the first term, which is 3x squared, and the second term, which is a 12, then you might say to yourself, well, these both have a common factor of 3, so let's go ahead and try to factor that out. So we have 3 parentheses, and then we'll reverse the distributive property to figure out what goes inside the parentheses. So 3 times x squared um, minus 4 equals 0. Okay. So now, hey, look at that. We factored it, but we might ask ourselves, is this completely factored? Okay. So if it's not completely factored and we can do something more, then we should continue factoring until it's all the way factored. So we factored it. The first thing that we did was we factored out the GCF. And now just inspecting this polynomial, this binomial that's inside the parentheses, that looks like a difference of squares. Difference of squares. So if you recall the formula for the difference of squares factorization, if I have a squared minus b squared, and those two are perfect squares, then we can factor that into a plus b times a minus b. Okay. So that means that I should be able to take this polynomial and factor it into x plus 2 times x minus 2. And we can't forget that we factored out that factor of 3 at the very beginning. Okay. So it looks like we can solve this one by factoring, and that's all well and good. The next step will be to apply the zero product property, which allows me to take this factor here, x plus 2, set that equal to 0, and then solve that. So if we solve that, we'll subtract 2 on both sides. We'll now have x is equal to -2. That's one of our solutions. Or we can go ahead and look at this other factor, x minus 2, set that equal to 0, add 2 to both sides, and we'll get x is equal to +2 from this linear equation. So we can say to ourselves, at the end of the day, the solution set that we were looking for is -2 and +2. And that equation was solved. Okay, but this video is not supposed to be about solving quadratic equations by factoring. Okay, so what I want to do is kind of solve this exact same equation again, but show you how we could do it another way. Okay, so if you need to, take a moment, pause the video, and maybe go walk around for 5 minutes to sort of cleanse your palate, if you will. What I want to do now is look at the same exact problem. 3x squared minus 12 equals 0. Now, if we are dealing with a quadratic equation where we have x squared minus some number, I'm just going to put c for a constant, okay, equals 0, well then an equation of this form is missing the b term, the one that usually has an x with it. So we have x squared, we have a constant, but that's all we're dealing with here. Okay. So what you might say to yourself is similar to solving a linear equation. We want to get the x squared by itself. So what if we isolate the squared term first? Okay. So let's think about what that's going to look like over here in this problem. Well, if I wanted to um, sort of cancel out this -12, you guys should know all we need to do is add 12 to both sides of the equation. So -12 plus 12, those guys cancel out. And now we have 3x squared is equal to +12. Okay. Well, if this were a linear equation, we would try to get the x by itself, but in this case, it's a quadratic equation. Let's try to get the x squared by itself. So in order to cancel out the coefficient of 3, we'll divide by 3 on both sides. Okay, so the 3's cancel out since 3 divided by 3 is 1. We have x squared left is equal to 12 divided by 3, which is 4. Okay. Well, now we get to use something called the square root property because when we're solving equations, what we're trying to do here is get x is equal to a number, or x is equal to a set of numbers. And we know that for quadratics, we should be getting most of the time 2 solutions here. Okay? So what you need to be thinking about a little bit here is that there's something we can do to cancel out this second power. Okay. So if you recall our video on simplifying radicals, I mentioned that the second power and the square root are opposite operations. So the square root property is basically this concept that if we have x squared is equal to some number, let's say some number c, and imagine that we had just added the c over to the other side here, and that's how we got it to be a positive c. Well, to cancel out the second power, just like we did when we were solving or simplifying radicals rather, all we did was take the square root of both sides of this little equation, right? Because the square root has an index of 2, we should know that the square root and the second power, the square, cancel each other out. So what we'll be left with is x is equal to, whatever the square root of c is, I'm going to leave that as the square root of c for now. Okay. But one very important thing here is that we know we should be getting two solutions from quadratic equations. And so you may hear some people uh, express it that if we take the square root of both sides of this equation, in other words, if you take the square root of something squared, that you'll end up getting the absolute value of x. Okay. Another way that other instructors describe this is that whenever you take the square root of something squared, you have to introduce a plus or minus symbol. Okay. Why are we introducing the plus or minus symbol? It's because the solution set for these quadratic equations should have two solutions. And when we're applying the square root property in order to sort of force that equation to give us the two solutions, um, we need to say, well, this is going to be plus whatever the square root of c is, comma, negative whatever the square root of c is, and that will be our two unique solutions. Okay. So there are some cases where you will end up with only one solution. For instance, if c happened to be 0, then if you were to get the square root of 0, which is 0, positive 0 and negative 0 are still 0. Okay. So I'm pretty sure that's the only case in which you'd only get one solution. In most other cases, you will get two solutions. Um, so let's go back to the equation that we were trying to solve using the square root property. Once you've isolated the x squared term, then we can go ahead and apply the square root property. So I'm just going to copy this again. And now I will take the square root of both sides of my equation. So now I have x is equal to, since we know that the square root cancels out this second power, I need to also introduce a plus or minus symbol. And then we also need to simplify whatever the square root of this number is. The square root of 4 happens to be 2. Okay, so this is one way to express your solution set. We have that our solution x is equal to positive 2 or negative 2. And that's exactly what we found when we solved it by factoring. We have one solution that's our positive 2 and one that's negative 2. So either way you approach this, whether it's by factoring or by using the square root property, you will get the same solution. Okay. But the reason why we're introducing the square root property right now is because not every quadratic equation that you encounter is going to be factorable. Okay. So that's one reason. Not everything's going to be factorable. And then the second reason is that even though some may be factorable, if the quadratic equation is set up in the right form, uh, it's usually quicker to apply the square root property in some of these cases. You're going to have to figure it out for yourself by looking at some examples. And so I want to run through some examples just to make sure that you guys have some sort of fodder so you can go ahead and study what those other examples look like. So if you jump into the PowerPoint where we left off, we run through this use of the square root property here. Okay, and we get our two solutions, plus or minus 2. Okay, but I also have some example problems here. Okay, that you can work through them, and if you need to go to the tutoring lab and get them checked out, then make sure you do that. But we're going to go ahead and jump in and do all of these examples here. Okay, so first, let's take a look at the A, which is x squared minus 49 equals 0. Okay. And let's go back over to the document camera because I think that when you watch this played out in real time, it makes a lot more sense. It starts to sink in, okay? So you might say to yourself, all right, if I want to factor, usually my quadratic equation is in the form ax squared plus bx plus c equals 0. That's what we typically call standard form. But if I'm missing the bx term and I only have ax squared plus or sometimes minus c equals 0, then this form is going to be an excellent candidate for trying the square root property. Okay. So you might look at this quadratic equation and say to yourself, well, Mr. Aguilar, these two terms, they're both perfect squares. And we're subtracting one square from another square. Can't we just use the difference of squares formula here and then factor it? Well, in this case, you can. Okay, so if you want to do that, pause the video and try that on your own. But we're trying to learn a new technique for those cases where you may not be able to apply the square root property. I'm sorry, the zero product property right off the bat. So let's try to use the square root property. So the square root property says, let's try to go ahead and get this term isolated if we can. We want to get x squared by itself. So how do I cancel out the negative 49 to move it over to the other side of the equation? Well, there, we'll go ahead and add 49 to both sides of the equation so that we can cancel out the 49, and now we'll have x squared is equal to 49. Okay. Then the square root property says if I have x squared is equal to c, some constant, then I know by taking the square root of both sides, x is equal to plus or minus the square root of c, whatever the square root of c happens to be. If you can simplify it, you simplify it. If it's not a perfect square, then we're going to have to do some work by simplifying that radical expression. But for this problem, x squared equals 49. If I take the square root of both sides, then I should know square root cancels out the square. X is now equal to plus or minus, what is the square root of 49? Well, that's just 7. So my solution set can be expressed as negative 7 or positive 7. Those are my two solutions. Okay, and you're done. So let's take a look at the second example here. On the PowerPoint, B is the quadratic equation 2x squared minus 16 equals 0. And we could do something similar here. We're going to go ahead and get the squared term by itself. So we'll sort of box in this guy just so that we can identify we want to get this by itself. So to do that, we'll just add 16 over to the other side of the equation. Okay. So now we should have 2x squared is equal to 16. But we have to ask ourselves, is the x squared isolated, or can we cancel out that coefficient? Okay. So when we say isolate the squared term, what I'm really trying to get you guys to do is just get x squared by itself. Okay. We don't want a number times x squared. We just want x squared by itself. So we might ask ourselves, how do we cancel out this 2? Well, since 2 is being multiplied by x squared, we can divide out the 2 to cancel it out. So 2 divided by 2 is 1. And that means I'm just going to have x squared left. And that's equal to 16 divided by 2 is 8. And right now you might start to feel the gears inside your brain grinding a little bit, because if we go forward with the square root property, you're going to notice that if I take the square root of both sides, certainly I'll just get x by itself. And I have to get used to remembering the plus or minus symbol here. But the square root of 8 is not a perfect square. So in most cases, your homework platform is not going to accept the square root of 8 until it's simplified completely. So if you have a non-perfect power, in this case, a non-perfect square, then you have to simplify the radical by hand. You won't be able to do this in the calculator. So if you recall from the video on simplifying radicals, what we need to do here is take our radicand, which is 8, and build a prime factor tree so that we can get the prime factorization. So 8 is made up of 2 times 4, where 2 is a prime factor, and 4 can be broken down into 2 times 2, and there we have nothing but primes. So 8 is equal to 2 times 2 times 2. But since the square root has an index of 2, we're trying to cancel out anything to the second power. Okay, so that means we can rewrite this as 2 squared times 2. And then if we're trying to take the square root of 8, then that means that we are trying to take the square root of each of these factors individually. Okay, and to be proper, maybe I'll throw an extra square root symbol there. But in any case, excuse me, we should end up with 2 times the square root of 2. Okay, so this is the form that your homework platform is going to take. It will not accept the square root of 8. Your solution needs to be x is equal to plus or minus 2 times the square root of 2. Or sometimes we just say 2 root 2. Okay. So you can just express that as plus or minus 2 root 2 if you want to see it written out in its entirety, the two solutions. Our two solutions are going to be negative 2 root 2 and positive 2 root 2. Remember, that's what plus or minus means, that we have a positive version of that solution and a negative version of that solution. But there we go. We have our two solutions, so we should be good since our quadratics mostly yield two solutions. Okay. So if this feels like it's going fast, make sure you pause the video and maybe rewind it, rewatch this section, and see if you can follow along. Or better yet, quiz yourself by starting this part of the video over and then just stopping to make sure that you know that you basically can carry out the same steps and that we're going to be doing the same things. So like check yourself against the video. Um, then let's take a look at another example. So C from the PowerPoint says we have x plus 7 squared is equal to 24. And on the face of it, this doesn't look exactly like the last couple of problems. And the reason why is because we have a binomial inside the parentheses, and then that whole binomial is squared. So I know what some of you guys are thinking. You're thinking, well, maybe I should write this x plus 7 twice and then distribute that out. You could do that, but it's going to cause a lot more work for you. And so there is a simpler way to approach this, and that's just remember what the square root property allows us to do. It says that if I have something squared equal to something else, I was about to write a 24. Let's say it's equal to a constant C, whatever that number happens to be, then all you need to do is remember that to cancel out the second power, or the square, take the square root of both sides, and then get x is equal to plus or minus whatever the square root of C happens to simplify to. Okay? So even though this doesn't look like just x squared, we can still say, what if we took the square root of both sides of the equation, right? So just like solving linear equations where you are comfortable adding something to both sides of the equation or subtracting something from both sides of the equation, sometimes you multiply something by both sides of the equation or divide something from both sides of the equation. So square root is a function or an operation that we can apply to both sides of the equation. As long as we introduce that plus or minus symbol, we should be safe. Okay, so I'm just gonna rewrite this problem so that you can see the original without me writing over it and adding a bunch of other symbols into it. But We're going to apply that square root property by simply taking the square root of this big thing and taking the square root of this. So we applied the square root to both sides. Okay. You should know that the square root cancels out the second power. And so what we'll be left with is x plus 7, and that's equal to, can't forget this, plus or minus the square root of 24. Okay. Well, pause and think about this for a moment. When we're solving our equations, we want to get x by itself. Currently, we don't have x by itself because we have a plus 7 here. So you might ask yourself, how do we cancel out that 7? But we're getting a little bit ahead of ourselves. What you really want to focus on now, once you've taken the square root of both sides, the next thing you want to focus on is simplifying the radical. Okay? And if that's not a perfect square, then we won't be able to do that in the calculator, right? Remember from the last video, I said if you take the square root of some number and you get a decimal, then we're going to have to do that by hand. So just keep that in mind. We have to do this by hand. We're going to build a prime factor tree for 24. So 24 is equal to maybe 3 times 8. And then 8 is equal to 2 times 4. And then 2 times 2. Okay, so our prime factorization of 24 is equal to 2 times 2 times 2 times 3. Okay, and the square root is going to cancel out anything that's squared. Well, we have a pair of 2's, so this is like taking 2 squared times, we don't have another pair of 2's and we don't have another pair of 3's. So we're just going to sort of squeeze that back together, just multiply the 2 times 3 and get a 6. Okay. So if we're trying to take the square root of 2 squared and 6, since those make up 24, then I know that the square root gets canceled with the square, so I should have a 2. And then the square root of 6, since I don't have a second power, needs to stay inside the radical. And then I can put my plus or minus symbol there in front and rewrite my equation. So this should say x plus 7 is equal to plus or minus 2 times the square root of 6. Okay. So remember, if you're struggling with following along with simplifying the radical, then go and revisit that video on simplifying radicals, because that should start to become second nature. Always simplify your radical by making a prime factor tree, unless it's a perfect square. Okay. But we're trying to solve this equation and get x by itself. So the next trick that you want to do here is something that you've already been doing, which is how do we cancel out plus 7 to move it over to the other side of the equation? Well, we're just going to subtract it. So subtract 7. And I'm going to subtract 7 and place it right here in front of the plus or minus. Okay. So as I write this down, I know I'm going to cancel out my 7's. I have x is equal to negative 7, since I subtracted it over to the other side, plus or minus 2 times the square root of 6. Okay. And this might not look or feel like it's a complete answer, but the whole process here is that we're trying to get the x by itself. Okay. And we've done that. This number here, negative 7 plus or minus 2 root 6, is just a number, as ugly as it looks. We could put that in the calculator, and really it's two numbers. So I'm going to start with this negative 7 plus 2 root 6. I'm going to put that in the calculator. Negative 7 plus 2 times the square root of 6. And that's just approximately negative 2.10, blah, blah, blah. A lot of extending decimals there. Okay. Similarly, negative 7 minus 2 root 6 is just another number. It's not the prettiest number I've ever seen. Um, negative 11.89897949, whatever. Okay. But these are just numbers. So if we needed to like place them on a number line, we could get their approximate position just by putting them in the calculator and seeing what their decimal representation is. Okay. But you need to get used to saying to yourself, as long as I get x by itself, x, not x squared, not 2x, not negative x, as long as it's just x is equal to this expression, then you're done. Okay. So realistically speaking, there are two solutions here. The first solution is negative 7 minus 2 root 6. And the second solution is negative 7 plus 2 root 6. It doesn't matter what order you put that in, but those represent your two solutions. And so I do want to remind you guys that there's a reason why we introduce a plus or minus symbol, and that is simply for convenience sake. It is inconvenient to write out this number, sort of to write it out twice when these two solutions look almost identical with the exception of the minus sign or the plus sign in between the constant term and the radical term. So instead, you might simply write your solution set as negative 7 plus or minus 2 root 6, just as we did when we solved the equation. Okay, so either of these will be acceptable, but you have to get used to this idea that we can, if we have two solutions that are what are considered conjugates, that if they look the same with the exception of the symbol in the middle, then we can just condense them into writing it one time, but putting that plus or minus symbol in the middle so that we can conveniently write less characters down. Okay. And that's going to be really useful for you guys later on. Okay. So I do want to go over one more example, the last one from the PowerPoint, and I think it's going to be an instructive example. It might leave us on a cliffhanger a little bit though. Okay. So let's look at example D. X squared plus 1 is equal to 0. Let's solve this using the square root property. So what I need to do is get the x squared by itself. So I'm just going to go over here and subtract 1 from both sides of the equation. These 1's will cancel out, and I'll get x squared is equal to negative 1. Okay. Then you might say to yourself, okay, well, we can go ahead and apply the square root property here and here. And we know that the square root will cancel out the square so that it leaves behind just x. And that's going to be equal to plus or minus whatever the square root of negative 1 simplifies to. So we'll grab our calculator and we will take the square root of negative 1. Well, that's weird. The calculator didn't let me do that. Maybe I made a mistake. I could try again. Let's go ahead and clear this, the square root of negative 1. It's still giving me this error, and I'm certain that I'm typing this incorrectly. So what's going on here? Well, if you remember our video on simplifying radicals and our discussion of what a square root means, remember that the square root of negative 1 is asking us what number, when multiplied by itself, gives you negative 1. Or results in negative 1. Okay, what number when multiplied by itself results in negative 1? So we might say we have something squared equals negative 1, and that's what we're looking for. We're looking for this missing piece. You might take some guesses. You might say to yourself, well, maybe 1's going to work. Well, if I had 1 squared, that equals positive 1. So that's not going to work out because we're trying to get a negative 1 here. And 1 times 1 is not it. It's not going to become negative. So you might say to yourself, well, what about -1? What if we squared that? Well, remember the definition of squaring means that we're multiplying -1 by itself. And -1 times -1 is a positive one, since a negative times a negative is positive. Okay, so that presents a problem. Okay, so what are we going to do here? Okay, you may vaguely recall from your high school math, or maybe you've heard about it online, that there's something called imaginary numbers. Okay, and the whole idea behind imaginary numbers is that if we define a square root as the opposite of squaring something, we have to ask ourselves, can we square a number and get a negative? And as we understand it now, there's no real number, positive or negative, that if you multiply by itself is going to give you a negative. Because a positive times a positive stays positive, and a negative times a negative becomes positive. So how can we get a number times itself to give us a negative? We have to invent a new class of numbers. And so that's exactly what some mathematicians a long time ago did. They said, let's define a sort of separate variable. Let's define this variable I to be equal to the square root of -1. So this is just kind of an aside, a little bit of a history lesson of how they came up with um, these imaginary numbers is what they eventually became known as. And if they said, okay, well, let's just call the square root of -1 I. What are the properties of I here? Well, let's see. If I have I and I squared it, that would be equal to the square root of -1 squared. Okay. Well, if I remember that the square operation and the square root operation are opposites of each other, they should cancel each other out. And so I squared should just be equal to -1. And so there we have it. We sort of defined I to just be the square root of -1. And it has this property where if you square it or multiply it by itself, you get a negative. Okay. So we call I the imaginary unit. And even though it's a god-awful name, imaginary numbers, um, it stuck. Over time, over the centuries, we got stuck with this name. And so we're going to continue calling these things imaginary numbers. So anytime you have the square root of a negative number, especially the square root of -1, we're going to have an I next to it. Okay. And so what you're going to see as we get into some more complicated quadratic equations is that we have to deal with um, these radical expressions that end up giving us imaginary numbers. So already we can look forward to some complications here. So first, we've seen that when we take perfect squares and take their square root, there's not a problem. The square root of 25 is 5, the square root of 81 is 9, and so on and so forth. There's some really nice numbers that you can take the square root of. Then there are some less nice numbers that you can still take the square root of them, but they result in a radical expression. It doesn't seem all the way simplified, and yet it is. Okay. So now we have this third class of numbers, this third class of solutions to quadratic equations that will result in um, numbers that include this imaginary unit. Okay, so in the next video, I'm going to talk about solving quadratic equations using the quadratic formula, and I'm also going to give a little bit of a primer on imaginary numbers so that they are a little bit less mysterious and that you know how to work with them. Okay, so look forward to the next video, and I'll see you guys later.